Hey, how's it going? In the previous video in our series, we spent a lot of time cleaning our code up. It was looking nice. But now the next thing I want to do is see this rectangle model. We have hard-coded all of these vertices, and I fast-forwarded that code because it is not fun. The moment we get anything beyond, really the moment we get to a rectangle, we should be not hard-coding it. So what I want to do in this video is just set things up so that we are loading in object models.objs. Now, an object model is a kind of text format. So if we go to models and then this cube.object, if it wants to load it. Oh, okay. Yeah, don't do that. All right, so let me just go into the code. So we go to this cube.object. We have this text description. It's very readable. So we have vertex, X, Y, Z, vertex texture, U and V, S and T, if you will, vertex normal, X, Y, Z components, smooth off, so we're not using smooth shading, and then faces. So the way this goes is these goes vertex, texture, normal. Vertex, texture, normal for all of these. And they're one indexed. So instead of in computer science, you index things at index 0. This is going from index 1. So this is saying the first face has 4 points. It's the first vertex, the first texture, the first normal. And look, it is a fun exercise to dive in and read this data and write a loader, but another equally fun exercise is not to have to do that. So there's this library called Tiny Object Loader, which is very, very useful, which I'm going to be using. It's a header-only library, pretty similar to STB image. And yeah, I'm going to be using that to load stuff. So note here that we've got this minus sign. This means that the file, yes, it's in the folder, but it hasn't been officially added to the project. We could use it without doing that, but it's a little nicer. I just go right click and add existing item. Then go over to view, grab my tiny object loader, add it in. Now we can see that yes, it is officially a part of the project. It just makes things look nicer. So this is going to be very similar to the image file. So for that reason, I'm actually going to kind of copy these image and stuff. So I'll go add new item. I'm going to call this, I forget. I think I'm going to call this object loader. So I'm going to go object loader.h. Awesome. Okay. Then I'm just going to grab all of this. Yep, so we're in the util namespace. We'll go load. Let's go load model from file. We don't need that. Okay, so what this does is it loads a model and it's going to return a set of vertices, which is a vector of floats. And we're going to take something else as well. So let's say we get some models and then we put them in our game, but they're kind of too big or too small or something, or they need to be rotated a little bit. So instead of doing that every frame, it's a great idea to have a kind of a transform matrix that we pass in. And to apply that to to the vertices as we load them, bake that transformation in so we don't have to worry about that later. Okay, cool. So now we'll create source code for this. We'll go add item. That will be objectloader.cpp. Awesome. Gonna be lazy. Gonna grab all of it. Okay, so we're gonna go objectloader.h. Then if we go to this tiny object loader, it says that we need to define tiny loader implementation. Okay, so that needs to go here. Like I said, it's actually very similar to STB image. Oops. Okay, so we have this vector of floats, which is like our bin. We're going to throw all of our model data in there, then we return it. Cool. So we're done. Just kidding. So we need to use tiny object loader to load this file and get all the stuff. So there's going to be a bit of typing here. Just bear with me for a second. All right, so we're back. So what we're doing is we pretty much need to look through all the shapes, materials, and all that. So I've just preset these variables. They are populated by the load object method. And if that fails, then we can print out the error which is associated with that. If it succeeds, then we go through here and we grab the positions, the normals, and the texture coordinates, and we apply a pre-transform. So the reason I'm sticking this 1 on the end is because we're doing a 4x4 transformation, including translation. But then when we come down to do the normals, we just want a 3x3. You may remember from previous video, 3x3 is pretty much just scaling and rotation, whereas a 4x4 includes translation. So that's great. I just realized we should, of course, be normalizing this. Okay, awesome. Because we might be scaling things and we still want the normals to be normalized. Otherwise the lighting goes off. So great, then we push all of those back. So we see the order we're going is position, then texture, coordinate, and then normal. We haven't really looked at normals yet in this series, but we basically use them for lighting. Then we return that. Awesome. Okay, so let's create an object which uses that. Basically, we'll redo the rectangle model as a more general sort of thing. So I'll make an object model.h. Okay, and I'm pretty much going to copy paste all the code. So object model. Actually, I'm going to rename that. Okay, so we've got that. We're also going to have our pre-transform. So I just noticed we actually don't need to store the vertices explicitly. Not necessary at all. We just use them to create the mesh, upload that to the GPU, and then we're good. Okay, cool. So then we go over to the object mesh and we'll grab all of this. Right, okay, so back to it. Going to include that object mesh. Go ahead and rename that. Okay, good. We should have vertex count. It's complaining about this. All right, so okay, so we want to load the model from the file. We need the file name, which is within the create info. Or maybe not. Okay, so what's going on here? Oh yeah, no, this is dodgy. Okay, this is a const string. Good, okay. Then vertex count will be, now there's complaints about this sometimes because size returns a size t, which is a pretty large integer, like a long or some format like that. What we want is we want to get that into integer. Doesn't really matter that much. Okay, so create buffer, create vertex array, awesome. The stride will be 8, because we have 8 attributes per vertex. This is great. I think we can change this to static draw. Static draw is a set once sort of format. Might be some optimizations there. So I'll make note of this. So we have position is attribute 0, text coordinate is attribute 1, and normal is attribute 2. Turns out if we don't declare all of these things, the model simply won't show. So Even though we're not using them in the shader, we still will declare them. So attribute, yep, that's fine, that's fine. And we just add the normal there. That is attribute 2. It has 3 numbers in it. They're floats, don't normalize them, so GL false. They start 5 numbers in to the buffer. And then we want to bind that attribute to index 0 of the buffer. Awesome. Cool. So then we just need to yep, that's fine. That's fine. Great. So now we're going to use that. Now, just briefly, I'm going to go into the scene. Just check something. Yeah, cube. Yeah, that's fine. That's all good. Okay, so now I'll go to the graphics engine. And it doesn't hurt, we can keep the rectangle model there, but we're going to go include object model, object mesh. Yeah, so I like to use this general rectangle model just as a quick and cheap way of making like custom rectangles for bounding boxes and things. So if I'm just testing out an object and I want to test like an enemy's behavior, then I'll just load a general model. I won't load an actual like model file, and I'll just work with that, get that working. It's similar to like when you're writing a song, play it out on acoustic guitar first and then bring the full band in. Okay, but now this is going to be an object mesh. Okay, and then just give it a second. Come on. Okay, good. Then I'll just go down to create models, and this is going to complain. So we're going to have mesh create info. File name is going to be, what is it? It was models/cube.obj. Awesome. Okay, and then the pre-transform. For now, I'm going to set GLM. Just going to set that to the identity. And the cube model. Yeah, I'm going to go new. Awesome. So let's give that a shot. Let's see if that works. Load model from file. Load model from file. Ah, of course. So I forgot to put this within the correct namespace. Awesome. Good. Now let's try that. Okay, so now we have it. It's working. Now, when I did this in the past on this machine, it didn't load the footage in time, so I'm just quickly going to confirm. There we have it. It's working. That's cool. Okay. Alrighty. So what we needed to do to get that to work, for some reason, it's probably a DSA thing for OpenGL 4.5 direct state access, is this needs to be at dynamic storage bit, not static draw. Okay. So let's have a little bit more fun with this. So what we're doing is we're loading this with the identity. Now, if we load this with the identity times an amount, that will scale it. So this should be the same cube, but just scaled down. I think it has to be a float. Yeah, there we go. And there we have it. See, we have the same cube, but just shrunk. So yeah, we can load object models, we can apply pre-transforms to them, and yeah, this gives us a lot of power. Okay, hope you had fun, hope you learned some stuff, and I'll see you in the next one. Bye.